All right, I had some requests for section 3.3 to do a few of the tougher problems out of it. So let's look at one like this. I just pulled these straight out of the Hawks. Okay. So we're given a statement: if our team wins tonight, then we will compete in the tournament. And it says if we will not compete in the tournament, then our team did not win tonight. The converse, inverse, contrapositive, or biconditional for this statement. So on these, you just want to look at the two statements that were given. So the first part says our team wins tonight. We can call that P. Right? And then the second part says we will compete in the tournament. We can call that Q. Okay, so those are our two statements, P and Q. And the thing that we have here, the way we would write this statement in logic symbols would be like this, where we got the way you read that is if P then Q. We got that double lined arrow stands for, it tells us it's an if then statement. So let's look at what we would have to do to change this thing into the statement it gives us. It says if we will not compete in the tournament. So not competing in the tournament, that's going to be the negation of Q, right? Q was we will compete in the tournament. So if we will not compete in the tournament, that's the negation of Q. And that's the if part, so it's going to go on the left side of the arrow. Then our team did not win tonight, so that's going to be the negation of P. We started out with our team wins tonight and changed it to our team did not win tonight. So got that little squiggle on that one too. So what we've done, we have switched these. Right, so we switched the P and the Q, and what else have we done? We've negated the P and the Q. So if you switch the two statements and you negate them, then this is the contrapositive. It's contrapositive. So what would the other ones be? So if we just switch them and did not negate them, so if we just had Q then P, that would be the converse, where we just switch. If we just negated each one, but we didn't switch their places, that's the inverse. And then this one here, this biconditional, that's the easy one, okay, because biconditional always says something like if and only if. So the biconditional is always going to have some type of wording that's equivalent to that in there. So converse, we switch the two statements. Inverse, we negate the two statements. Contrapositive, we switch them and negate them. And then the biconditional is kind of on its own. Okay. Look at the next one here. And using De Morgan's laws, this one says use De Morgan's laws to write an equivalent statement without using parentheses. So we're trying to get rid of the parentheses. So I'm going to rewrite what we're starting with here. Okay. So De Morgan's laws say that we want to get rid of the parentheses. We can kind of, you can think about it like distributive property. We want to distribute this squiggle in here. But when we do that, we got to take, this is the OR symbol, this V symbol here. Okay. That stands for OR. But if we distribute that squiggle, we distribute the negation, then we got to flip that sign in the middle. So if we do that distribution there, then we're going to end up with squiggle, squiggle P, and squiggle, squiggle Q. Okay, so we've added a squiggle to both of the things on the inside, and then we flip the symbol from OR to AND. Okay. And on this, we've just got one little thing we can do to simplify, and we'll be done. So you can kind of think about the squiggles like the negations like minus signs. So anytime we have two minus signs, they cancel each other out. So we can just call this P and Q. Okay. So let's do a similar one off to the side here. So like if we started with P and Q, and it told us that we wanted parentheses. Okay, then just kind of working the other way. How could we do that? Well, okay, so we just have to kind of think backward. All right, so what we could do is we could take out a squiggle. Okay, so we could put a squiggle out front, but we want to end up with P and Q, not squiggle P, squiggle Q. So that means we got to have a squiggle P here. That way the squiggles will cancel out, and then the same thing with Q, squiggle Q here. Okay. That way, when we distribute the squiggle, if we're working backward, the squiggles will cancel out. And then we started with and, so sorry about that. We want to end up with or. Okay. So you can do them both directions. Okay. Let's look at another problem here. When asking about De Morgan's laws, and De Morgan's laws tell us that certain statements are equivalent, and then it asks us to check these two statements with using a truth table. Okay, so it gives us most of the truth table here. We only have 2 columns we have to fill out. So the important thing is just take it one piece at a time. We're gonna work on this column first. Okay, work on filling that out. And if we look at it, the pieces we need, okay, inside the parentheses we've got if P then not Q. Okay, so that is this column. If P then not Q. And then we want to squiggle that whole thing. Right? This says we want to negate this whole thing. So all that means is we look at this column over here, and we want to negate all of those truth values. So that just means we switch it. So here this is false, so it's going to turn into true. This is true, so it turns false. True, so it turns into false. This is true, so it turns into false. Okay? So now we're done with this column. Okay? We're done with that column. So we want to work on this last column now. And for it, we need P or Q. So we're going to use the 2 beginning columns. We're going to use the P column and the Q column. And we're going to join these 2 with OR. And if you think back, you remember the rule for OR. If either one of the statements is true, then the combined statement is going to be true. Okay, so let's look. We've got true, true. So that's true. We've got true, false. So one of those is true, so it's true. Then we've got false, true. One of those is true, so it's true. And then on the last one, false, false. So if they're both false, the OR statement is going to be false. So now we've got our 2 statements, and if we look at them, the only way these 2 are equivalent is if the truth tables for if this column and this column match. But they don't, okay, because here this one's false, this one's true, so these don't match, so these are not equivalent. Not equivalent. Just take it one little step at a time. And let's look at another similar one. I didn't get all the instructions and things on this one, but we're just checking 2 more statements here. Okay. So looking at this first column here, the 2 pieces we need, or we want not P and not Q. So those are these 2 columns. And we want to combine them with if then, okay, with an implication. Okay, so the rule there, this is a little bit trickier rule. Okay, the only time an if then statement is true the only time an if then statement is false. Sorry, is if the first part is true and the second part is false. Any other time an if then statement is going to be true. Okay, so if we look here, the first row we've got false, false. Okay, so oddly enough, that's going to be true. Okay. And we've got false, true. That's going to be true. And the next one, this third row, is the only time we're going to get a false because the first part is true and the second part is false. That's what gives us a false on an if-then statement. And then on the last one, true, true, is going to be true. Okay, so if-then statements are a little trickier. You've got to get the rule down. And you got to remember the only time an if-then is false is if the first part is true and the second part is false. Otherwise, it's true. Okay. And then for this last column, Okay, we want squiggle P, that's this column, and Q, and we're joining these together with AND. So in order for an AND statement to be true, both of the other statements have to be true. So only when the first part is true and the second part is true, then it'll be true. Any other time it will be false. So if we look here, we've got true, false. So that's going to be false. They're not both true. False, false. Going to be false. True, true. Okay, that's what we need. So if we have true on both parts, then our compound statement is true. And on the last one, we got false, true. So that one's going to be false. Okay. And if we look to see if these are equivalent, well, they're definitely not equivalent. Okay, in fact, they're complete opposites. Okay, so this one is, again, not equivalent. Again, the only time these would be equivalent is if this column and this column match. Okay, exactly. They have to be exactly the same in order to have equivalent statements. Okay. One more example here. Okay, these can be a little tricky, so it says negate the conditional statement. So our rule says if we have some statement, if P, then Q, okay, and we want to negate that, okay, so if we want to negate if P, then Q, what we do is we take the first part, so we take P, and then we're always going to have and then we negate the second part, so squiggle Q. Okay, so that would be our negation here. Okay, so looking back at the statement we're given, this is the first part, this is like P, and then this is the second part, this is like Q. So we're going to take the first part, so even though it's messy, we're going to have squiggle A or B, and then we're going to have and then we're going to squiggle the second part, so squiggle C. Okay, works that way every time, okay, when we're negating a conditional statement.